Assalamualaikum guys, welcome to my YouTube channel Analytical Chemistry. I hope that you all are doing good and well and enjoying your beautiful days today and many more. So guys, our today's topic is about atomic absorption spectroscopy. But before I go to start my video, I'm going to discuss with you some important definitions you can say which are very important in analytical chemistry and in your topic atomic absorption spectroscopy. First of all, you have to know what is spectroscopy. So it is a combination of the two words spectrum and scope. Spectrum is originated from a Latin spectron, ghost or spirit, and spectrum means a set of specific number or the set of specific values or a set of digits, while the word scope means look or watch, and it is a Greek word. So spectroscopy means study of the specific values or the numbers, and it deals with the study of the electromagnetic radiations, and electromagnetic radiations include further ultraviolet, infrared, microwave, radio waves, cosmic waves, visible waves, and many other things. Every light is a combination of the different colors, and in the if the spectrum obtained is from visible region, then it is photometry. Now this one is the spectroscopy. Now we will further discuss what is spectrophotometer. It is an instrument that measures the amount of light absorbed by a sample as a function of the wavelength. Now we will discuss that what is photometer. The portion of atomic absorption spectroscopy which convey the light from source of light to the monochromator, and the nebulization, the conversion of liquid sample into the fine spray is called nebulization. Now what is the dissolvation? Atomic solid atoms are mixed with the gaseous fluid, and this process is known as dissolvation. Further we have volatilization. Solid atoms are converted into the vapor in a flame. That this process is known as a volatilization. Now what is the atomic absorption spectroscopy? Alan Walsh in 1955 was the pioneer of the introduction of the atomic absorption spectroscopy, and first spectrometer used in 1959. And when we study the absorption of the energy by the atoms in the flame, we call this technique atomic absorption spectroscopy. And its principle is what? Its principle is it quantifies or measures the absorption of energy radiation by the ground state atoms in the gaseous state. Okay, now you can see in this picture that first circle is small and the another one surrounding it is the ground state, and the further surrounding the large circle is the excited state, and the incoming photon of energy are coming and someone is absorbed, and after that they are going, which are you can say that emitted. Its equation is that delta E is equal to E1 minus E naught, delta E is equal to HV, and V naught that the lambda is equal to C over V. So it becomes delta E is equal to HC over lambda, where delta is the change in the energy, H is the Planck's constant, C is the velocity of light, and lambda is the wavelength. Now further we will see that the absorption is directly proportional to the concentration. Now the most important thing in the analytical chemistry is the instrumentation of that topic which you are going to be studying. This one is the very important thing. Instrumentation of the atomic absorption spectroscopy has the four principal components including light source, beam chopper, atomizer, monochromator, and detector. And you can see also diagram here. First one, halocathode lamp, through it will going to the chopper, further contains flame which contains your sample, further it's a monochromator which will go to the detector and detect electronics and the readout devices. Okay, your light source further contains three types: halocathode lamp, temperature gradient lamp, and electrode-less discharge lamp. Now another one is the beam chopper. It is present between the halocathode lamp and the flame, and it rotates and breaks the steady light into intermittent light, and this gives the pulsating current into the photocells. Third one is the atomizer, and electrons to be analyzed need to be in atomic state. Atomization refers to the separation of the particles into individual molecules and breaking molecules into the atom, and this is done by exposing the analyte to high temperatures in a flame to the graphite furnace. There are two types of atomization including flame atomization and electrothermal atomization. Monochromator. It's a very important part in the atomic absorption spectrometer. It is used to separate out all the thousands of lines, and it includes entrance slits, diffraction grating, and exit slits. Diagram of the monochromator including exit slit, photomultiply, grating, and entrance slits. Okay. Monochromator types are the prism monochromator and the grating monochromator. Further, we have a detector and readout devices. The light selected by the monochromator is directed into the detector, that is typically a photomultiplier tube, and whose function is to convert the light signal into an electrical signal proportional to the light intensity. Okay, so this is one is our the topic which include the basic instrumentation of the atomic absorption spectroscopy, its principle and its introduction, and many important definitions, including the starting in the chapter. So guys, if you like it completely, understand it completely, then go and like my video, subscribe my channel. Don't forget, please, and wait for my another video on another topic of the analytical chemistry, which is very helpful for you. Allah Hafiz.